This question involves us knowing a couple of circle theorems. Reading through carefully, we know that BOD is a diameter for the circle. Importantly, BC and AC are tangents to the circle. BC and AC are tangents to our circle. Now, we know for a fact that a tangent will meet a radius at 90 degrees. So I know that this here is a right angle. That a tangent meets a radius at 90 degrees. So this here is a right angle. And again, it doesn't look like it, and that's why it says here the diagram is not drawn accurately, because this doesn't look like a right angle, but we know, because we're told that this is a tangent, that it has to be a right angle. Now, finally, I know that two tangents from the same circle that meet at a point are the same length. So I know that these sides are the same length. This is a radius, and this is a radius. So I know that these two sides are also the same length. So what I have here is in fact similar triangles, because they share two angles and two sides. So here I can note in that this angle will also be 34 degrees. Knowing that this angle is 34 and this angle is 34, I can work out for either triangle the missing angle up here, because I know that angles in a triangle should add up to 180. And I know that so far I've got 90 degrees and 34 degrees. Don't know what this little symbol's here for. Let's change that. So I've got 180, and I need to get rid of what I've got so far, which is 124. And if I do that, I'm left with 56 degrees. So this angle in here is 56, which is the same as this angle in here, which is also 56. Finally, reading on to the bottom of the question, it asks me to find DOA, D to O to A. That's this angle here, the angle that's made by moving from D to O and then on to A. Angles on a straight line must add up to 180 degrees. I know that these two angles add up to 112. So this angle here is 112. So then all I'm missing is the 68 degrees that is in here. So there's our final answer, 68.